When you're collecting data in JavaScript, what do you grab? Probably arrays and objects, right? I mean, they're the classics for a reason. But sometimes the classics just don't cut it. Today, we're going to go beyond the basics and look at two really powerful data structures that can solve some super common and honestly kind of tricky problems. Okay, well, let's just dive right in. Imagine you need to store some data that's paired up with a key. Like user info tied to a specific value. What's the very first tool that pops into your head? For pretty much all of us, the go-to is just a plain old JavaScript object. It's familiar, it feels simple, and you know what? For keys that are strings, it works like a charm. But, and this is a big but, here's where things start to get a little weird. What if you need to use another object as a key? Maybe you've got these user objects and you want to map them directly to some data without having to use a string ID. If you've ever actually tried to do this, you've probably slammed right into some really unexpected behavior. And that, right there, is exactly why map and set were created. They are specialized collections, built from the ground up to handle the exact cases where our trusty objects and arrays just fall short. So let's break them down. So what is this limitation with objects that I keep talking about? Instead of just talking about it, let's actually see it in action. Okay, let's put this to the test. Let's say you try to use two totally different user objects as keys in a regular object. What do you think happens? You set a value for the first one, then you set a value for the second one. Seems simple enough, right? And boom, here's the kicker. Behind the scenes, JavaScript takes both of those unique object keys and smushes them down into the exact same generic string, quote, object object. So when you set the key for your second user, you're not adding a new entry, you're actually just overwriting the value you just set for the first one. Your object has only one entry and your data is gone. This is a classic trap. So how do we fix this? Well, this is where our first hero, the map, steps onto the scene. It's designed specifically to handle this exact kind of challenge. The magic is right there in the definition. Unlike an object, a map lets its keys be of any type. Seriously, it can be a string, a number, even nan, or, most importantly for our problem, another object. Okay, let's put these two head to head. On the left, with the object, any non-string key gets forced into being a string, which is what causes our collision problem. But on the right, with a map, the key keeps its original type and value. The John object is treated as completely distinct from the Ben object, no confusion. And just look at how clean this solution is. We create a new map and then we just use the .set method. We pass our user object, John, directly as the first argument, that's our key, and then the visit count as the value. The map preserves the object as the key. No string conversion, no overwriting, problem solved. It just works. And honestly, getting started with map is super straightforward. You've got .set key value to add stuff, .get key to pull it back out, .has key to check if something's there, and .delete key to remove an entry. Plus the .size property gives you an instant count. It's a complete, convenient little toolkit. Now, while map is all about those flexible key value pairs, our second data structure, set, is focused on one thing and one thing only, uniqueness. So a set is basically a collection where you literally cannot have duplicates. Every single item is guaranteed to be unique. If you try to add an item that's already in the set, it just does nothing. It just ignores it. And this feature is incredibly powerful. Let's circle back to our visitor's example. We create a new set. We use the .add method to add John, then Pete, then Mary. Then, John visits again, so we try to add him. And Mary comes back, so we add her again too. So, what do you think? How many people are in our set now? Just 3. That's it. The set automatically handled the duplicates for us. No extra code, no checks, no if statements. It's just a clean, super efficient way to maintain a list of unique values. Now I can kind of hear you thinking, this is cool and all, but a lot of my code and the libraries I use, they all expect plain objects. And that's a totally valid point. Luckily, it's incredibly easy to convert back and forth between these data structures. So say you've got an existing object that you want to upgrade into a map. You can do it in literally one line. The object.entries method turns your object into an array of key value pairs, which just so happens to be the exact format the new map constructor is looking for. It's simple, it's effective, it's great. And yep, you guessed it, going the other way is just as easy. The object.fromEntries method does the exact reverse. It takes something like a map, which is an iterable of key value pairs, and it builds a brand new plain object for you. This is perfect for when you need to hand off your data to older code that doesn't know how to handle maps yet. So once you get comfortable with these tools and how they can talk to each other, You basically unlock some new coding superpowers. Let's look at a really common challenge that suddenly becomes almost trivial. Okay, this is a classic. A real-world problem you see all the time, and a favorite interview question. You've got an array, it's full of duplicates, and you need a new array with only the unique items. How would you do it? Maybe a loop? A filter with index of? There are a few ways. But with a set, it becomes this beautiful one-liner. First, you create a new set from the array, which instantly, automatically throws out all the duplicates. Then you just use array.from to turn that set right back into an array. It's clean, it's super readable, and it's fast. This is a fantastic trick to have up your sleeve. Okay, so to wrap this all up, here's a quick little cheat sheet. Use a plain object for your simple string key data, your bread and butter. Reach for a map when you need keys of any type, especially objects, or if you care about the order things were inserted in. And grab a set whenever you need to enforce a collection of unique values, period. And that's pretty much the rundown. With a solid understanding of these powerful tools, the final question is really for you. Think about your own projects. Where have you written loops to check for uniqueness or struggled with object keys? What's that one part of your code base that could really benefit from the clarity and power of a map or a set?